Let's try to create a FE option based solver. So FE option is the runtime available source selections. Okay, so it is very useful tool to explicitly specify the source term, like when we work with the MRF form. Okay, so with the help of the MRF form or inside the simple form, we can source MRF type of the source term as a corollary force in everything inside the solver. Okay, so how to enable any of the other class of the solver with this source term? So let's explore that FE options. Okay, so how to do that? For that, first try to go to our install area and try to understand couple of the things. So let's say applications, solver, simple form, incompressible simple form. So simple form, if you look at this, its header file. Okay, it have this FV options, and depending on this FV options only, it enable us to add up the FV option inside the solver. Okay, so that is the basic idea. So along with that, what different entry required as a solver level, we require this FV IO options list.h file. Then we have to initialize the FV options. For that we require the create FV option.h file. So these two header files is required. Along with that two header file, if you look at the, let's say, U equation, we will see certain options. So here we are adapting the source term inside this matrix. Okay, we are constraining the source term and we are correcting the source term. Okay, so this is the few entries that is needed. But to facilitate these entries, okay, what is important, we have to resolve the dependency. So how to resolve the dependency? So for that, let's look at the make folder and look at the option files. Okay, inside the option file we require this one lib src fv option dot include file. What it is supposed to do, it try to link the required src folder. So I say required src folder, that means if you go to the here, you will see FV options. Okay, and ln include of this FV options, it facilitate what? It facilitate this one file, create FV option.h. So it available here. Just search create FV option.h file. Okay, so that file is available. And what did that file do? It just to initialize the FV options. So FV IO option list, and this is the FV option for that particular mesh. It try to initialize that option, nothing else. Okay, so this file is needed, so that file is available there. Okay, then what else we required? We required the FV IO option list.h file, FV IO option dot list file. Okay, so that is also available here. So this is also one of the header file that is needed to facilitate the FVIO list. Okay, so what different type of the FV options available? For that, this particular file facilitate this term. Okay, so that is what needed. So these two entries needed, so that is available from this. Along with that, whatever the compiled FV options, so that lib file is available inside the our release version of the library. So where we supposed to find it is here inside the platform src lib. Okay, so lib FV options, some class of the files available. Okay, FV function, yeah, this one. Okay, so lib FV options.so file is needed, that we can with the help of this one line we can inline with our code, and based on that, what going to happen, whatever the source code we want to incorporate inside the solver, it try to take into account inside the matrix form, or straight away we can code it as a solve equation form as well. So let's try to generate one more our new solver that will facilitate us for this class of source term. Okay, so for that let's look at very simple solver, and from that solver we try to enable this FV options, we compile it and we try to run this FV options. Okay, so that is the idea. So let's say application solver basic, let's say we look at the Laplacian form. Okay, so let's copy the Laplacian form in our area FV options. Okay, so if we look at the Laplacian form, okay, so let's first check its .c file. So inside of it we don't have a FV options, and so we want to enable the FV options on the right hand side. That is the idea. Okay, So what we supposed to do, we first, let's say, change the name of this particular file as a some additional name we specify to this particular file. Okay, so in case of this enabling this source term, what we supposed to do, we first, let's say, rename the our this solver. I say my Laplacian. Okay, and it is runtime selectable source term, so we say dynamic dym dynamic source form. Okay, so my Laplacian dynamic, or we can give let's say full name. Okay, so we say my Laplacian dynamic source form. Okay, so that is the name I want. When I change the name to directory, immediately change the name to the .c file. Okay, so then inside the make folder also make sure that we able to change this name here as well. So here and here, and without fail change it to the user. Okay, so just our template is ready. So first let's compile and check either we have any error or not. Okay, so that is the first part. One can check very quickly. OF 3.0. okay, w clean all. This is the executable, so no need to write as a wmac libeso. Okay, so we are, so our this new solver is ready, but now we want to enable the FV option inside of this solver. So we want to enable the FV option inside of this solver. What FV options we want? We want this simple FV options is equal to FV source. Okay, that's it. So in which file we want to modify this? If we want to modify in this file, so here I say equal to something like this FV options. Okay, so that is what we want to change this very simple equation, and then we say that it's supposed to solve this equations. Okay, so that is what we want. So we say we try to construct some temp matrix. Okay, temp T E Q N equations. Okay, so we generate these equations and then we try to solve these equations. That is what we are doing. Okay, so temp, okay, we don't have to set any name of this. Okay, let's say temp of this matrix name. That is what I'm doing. Temp of that matrix name. Okay, so we constructed this matrix, and after the construction of matrix we supposed to solve the matrix. So we say solve. What we have to solve? We say the T E Q N. Okay, so that is what needed. The same way what is we are doing in the U file, we construct that and we say solve that particular matrix. Here we have ratio term, so that's why we are equating here. In this case we simply say solve this. Okay, now if we try to compile it, just check what error we going to get. Okay, so temp was undeclared in the scope. Okay, first of all, so it's saying that temp is undeclared inside the scope. So let's try to look at the U file. We say FV scalar matrix. So let me check either it works straight away or not. Okay, so what I'm doing, I say, let's say in case of here, let's try to write down solve here. Okay, solve. Let me erase this. Okay, maybe it's working or not. Let's see. Okay, okay, so it's fine syntax wise, so no need to construct even that matrix as well. But what it's saying that was not declared in the scope. Okay, which one? This options was not declared in the scope. Along with that, U is also not declared in the scope. That is correct, because I copied, so it's supposed to be T, not U. Okay, so that is my typo error. Just check what else it says now the FV option is not declared in the scope. That is correct, because we didn't give the proper dependency inside the our option list. Okay, so if you look at the option list of simple form, you will see this one line. Okay, which line? This one. So we supposed to add up this line inside our list. Okay, so this line is needed. Along with that, what needed? If you look at this particular line, this one additional line is needed inside of it, our line. Okay, so this two line try to resolve this dependency error first of all. Okay, so let's check this. Okay, so till it's saying that it's didn't declare in the scope. That is correct, because we adapted that, but we didn't add few entries inside the basic code, like this entries that is needed. So inside this header files is required, so let's add up that header file, okay, from C area. Along with that, after the create field, we say create FV options. Okay, so wherever you have create field, after that try to add up the FV option. Okay, or after create mesh also you can write down this file, no worry. Okay, so FV option available. Now check. So with the help of that, we able to resolve the dependency. So what we did, we says that we want to incorporate the FV options for this scalar transport. Okay, so for let's say t variable, we want to incorporate this FV option inside the our main solver, and so we add that. Then we say that to resolve that, we have to add this FVIO list and the create FV option that will initialize the FV options. So these two, if we added, to resolve the dependency, we require the proper file, proper include file, that is FV option ln include and FV option. The two files we have to incorporate in the option area, and with that we are set with this particular FV options. Okay, now how to run this particular class of FV options? For that I already have a very nice tutorials. Okay, so let's try to look at that. So inside the test case, let's say FV options, some 2D diffusion class of the test case I have. Okay, so let's try to look at that test case. So let me first clean couple of the things. So if we look at here, so first let's try to create the environment from that particular place. Okay, so OF 3.0x w clean, sorry, not w clean, we say, let's say we require this, so we can say we want to delete this, or all w clean also available, no worry. Then we say block mesh. Okay, and check how the mesh is look like. It's very simple. Okay, so two-dimensional case with the peripheral wall everywhere, and temperature is one of the variable. That's it. Okay, so along with that, what we going to do, we set some variables. Okay, so let's say use the set field. Okay, so so let me check. Okay, I renamed that, that's why it's giving the error. So I say set field. Okay, so set field. So what it going to do, it try to set the value. Just check what the set field is doing. Okay, set field, everywhere it has a value. Okay, so we are defining the value t equal to 0, but for certain areas we say that set field equal to this value. Okay, so that is the initializations we are doing for that particular set field. Okay, so that is the initialization. Just check how the set field look like. So after the set field, you will see that the initialization is something like this way. Okay, so we are set with the set field. Okay, now along with that, what we have a few more, that is create box zone dot set field. Okay, so here we are constructing one box zone. Okay, so for that we are running very simple command. Okay, so with the help of that, we are constructing the box, okay, and that box we construct as a cell zone, and on the cell zone of that particular box we try to apply the source term. That is the idea. So how to apply the source term? For that we have a control folder. Inside that we have FV options. So inside the FV option, let's say heat source, okay, heat source is name of that particular entry, particular source term. And what we say that for that particular cell zone, we says that volumetric absorption, okay, volume mode absolute and ejection rate of the source term T equal to this value, okay. So and the cell zone is the box, select mode is the cell zone, and the name of the cell zone is the box cell zone. So let's look at how the cell zone is look like with this. So if I incorporate all the sets, you will see the box cell zone, okay, and this is the box cell zone. So very simple, out of the bigger zone we have this cell zone, and on that cell zone we are specifying certain source of that particular variable, okay. So right now if you see the temperature, okay, it's something like this way. Temperature distribution, it's something like this way, okay. Now let's run with this source term. So what we did, we says that we have a source term, okay, and on that source we are specifying the ejections, okay, of that particular source, okay. So that is what we are doing. Now let's run with the our new developed solver. So this is the my Laplacian source solver. So with the help of that we try to run it. So let's say keyword select zone, selection mode is undefined, in mode heat source scalar deficit source term, okay. Selection mode is undefined, selection mode is cell zone, that is perfectly all right, okay. Scalar implicit, that is perfectly all right. So where is the problem? Implicit coefficient, (27 to 30). This is coefficient correct. So let me check any other places this source term is available. So let's go to the OpenFOAM area tutorial, grep, okay. So it is available in Lagrangian some place, okay. So let me check this area, okay. So okay, so let me change this entry, okay. So that is the mass source, I say scalar, start time, end time, points, case of the point we say volume absolute, ejection this, okay. So within what particular time range we supposed to eject it, so that's why it is maybe giving us the error, that's it. Start time, end time, okay. Selection point, okay. So let me add up from this area, can be modified based on our requirement, that is what. So we say that name is heat source, fine, type active yes or true, okay. Then coefficient wise time, selection mode we say cell zone, and then we apply the cell. I think that will clear this entry, cell zone and cell. Then we say volume absolute T, correct. I think that will allow us to set the appropriately, it seems. Let's see. So start to end durations, and this is what we have. fine. Okay, so let's say paraFOAM, check how exactly and what exactly happened with that source. Okay, so here is the temperature. Okay, so this is how that is fine. Okay, sorry, I'm supposed to apply this ejection, not H, we say T. Okay, fine. Let me clean this, all the backup file. Okay, so let's run it. paraFOAM, and just check what happened with that our source term. Look, so sorry, this is what it is behaving as a source, and from there later on everything is propagating. Okay, so that is how from the one corner we initiate the, so at the beginning we start with this, okay, and at the end we have a source term that is propagating from one corner. Okay, so that is the how one can incorporate this. So for that what we did, we let me clean this area. Okay, we say heat source, okay, and scalar implicit source active, and then we say time duration, from what to what time we require that source term. Okay, so we have to say particular time within which we require the source term. Okay, so that is what is going, and ejection rate. Okay, so how we want to eject, and it is volume absolute value we are ejecting. Okay, so this is very simple way one can incorporate the FV option inside the solver, like what we look at here. Very quickly we able to define the FV options and manage the activation of FV options, and it's working very nicely.